Hi everyone. In this video, we are going to learn about linked list data structure. The agenda of today's video is what is linked list, how do we represent linked list, and what are the operations we can perform on linked list, and we will see what are the advantages and disadvantages of using linked list. Linked list is a data structure which is used to store the collection of data. We already have arrays which serve the same job, right? So arrays also store the collection of data. Then why linked list? So to understand about linked list data structure, let's discuss with a small use case, and we are going to compare with arrays data structure. So it will give clear understanding of why linked list and how linked list is going to perform internally. So the use case which I'm going to discuss here is we want to store student names who enroll for a particular course in alphabetic order. The use case here is to store student names in alphabetic order. Here, the students enroll for a particular course called CS and maximum number of seats are 50. Let's assume this is the requirement. Let's assume that initially there are few students already enrolled for the course. Then how the array looks like for this data? So initially, assume that already 5 students enrolled for the course and we have already stored in array in alphabetic manner. So if you notice it, this is already stored in alphabetic manner. So here we have created an array of size 15 because we are assuming that maximum number of seats for this particular course is 15. But currently only 5 students are enrolled for the course. So if a new student named Carmen joined the course, then what we have to do? What should be the proper position of Carmen? It should come after Bob. Means we have to insert Carmen at this position. That means that we have to shift all the elements right side. What are the elements? After Carmen, they should move to right. Then only we can able to insert Carmen at index 2. So this takes order of n time complexity. So insert Carmen takes order of n time complexity. This is already discussed in detail in arrays. Just I am adding high level. I am just discussing here. If Alex has withdrawn the course, what we have to do? We have to delete Alex. So deleting Alex means Bob has to move here, Carmen has to move here, Roxy has to move here, and then Tony has to move here. Again, we are going to take order of n time complexity. So both insert and delete operations in worst case taking order of n time complexity. And let's assume that only 5 students have enrolled for the course. Then we are going to waste almost more than half of the space. So this space we are going to waste it. So to solve this waste of space, already we have created dynamic arrays, right? So dynamic arrays also we have already discussed how it is going to help us. Even though dynamic arrays grow and shrink in size whenever it is required, still there is some overhead, because how dynamic arrays are working, whenever we have to perform shrink operation or grow operation, we have to first create a temporary array and copy elements from old array to temp array, copy elements, and finally change reference to temp array. So the dynamic operations, even though adding and deleting takes order of 1 time complexity, still at some particular time we are going to perform these operations. Even though it is order of 1 amortized time complexity, but still it takes some extra amount of time. So now how we will solve it? So let's see. So for example, instead of creating arrays, let's see, I'm just creating variables. So whenever a new student has been enrolled, I'm just creating a variable. So that case, how we will do it? Just create Alex here, and then new student named Bob join. Then create Bob here, and new student named Danny. So create all the variables separately. So in case of arrays, these will be in contiguous memory locations. So the memory locations will be always contiguous. When we are creating a variable, then it will be randomly allocated, right? So for example, Alex created at 100 and Bob created at 200, Danny created at 300, Roxy created at 400, and Tony created at, and in between there can be some other variables or memory has been used by different processes. This is fine for one or two variables, but if you are having more than 100 variables, maintaining 100 different variables is very difficult. So that's the reason we have used arrays, but still arrays are not going to perform well. So that case, so after creating these variables in memory, somehow if I'm able to link after Alex, Bob is created. After Bob, Danny is created. After Danny, Rox is created. Somehow if I can able to maintain this structure, then we can achieve what exactly we are looking for. Let's see how we are going to do it. So here Alex has been created at 100. So this is my first element. I will mark it this as first. So when new element Bob, when new variable got created, somehow I should be able to link after Alex, I should be able to get Bob. So in case of arrays, immediately we can get it right. Alex after that Bob just by index. But these variables are randomly allocated in memory and then it is not possible. So just I can print Alex and after that which element is there. So somehow if I can link it by using this address. So instead of just storing the value in a variable, if I store both value and an address of the next element which got created, even though the elements created randomly in memory, but still I can maintain list in sequential order. Normal data types like int, float, double, we are not able to store more than one value, right? Int means only integer value. So what we have to do? We have to create a object. So instead of creating simple string variable or simple integer variable, we are going to convert these into objects. So now my object is going to contain what is the value and what is the address of the next element. So this one I am naming it as next. So how we will achieve this? We will write a user defined class. So I am naming it as a node. So what I am assuming it, I will be having object which will store value and as well as the address of the next element. So first, for example, I just got Alex. So I'm creating an object. What is the object type? Node class. So I'll create a object with value Alex and then currently I don't know who has joined after Alex. So currently it will be null. Alex got created at address is 100. Now new student named Danny got created. Then this is, assume that this is 300. Then simply the address of the Danny, the address of this particular node, we will store it in next. Means it will be updated to 300. Means we are forming a link between these two elements. So this is what exactly linked list. So this way, whenever we have to add a new student to the existing list, just we will create one more object and then we will append or we will insert in the middle wherever it is needed. So this is what exactly linked list do. So now let's see how do we represent node class. We have already seen that the elements in the linked list are not simple data types. These are objects. So elements in the linked lists are known as nodes. So what is the term we are using? Node. So this node always comprises of two things. Just now we have seen first one is value. What is the value we are going to store and address of the next element. So how do we create it? In case of Java, we will create a class and here class name I am giving it as a node and we have to store the value. So in this case it is string type. For simplicity I am giving values of type int. And what we have to store? Address of the next element. How do we get address of the next element? Just we have to use the node and we'll give next. Now let's talk about linked list operations. So let's assume that we already have a linked list in picture which is having 3 nodes. We will write it as this way or we will write 10 and then we will give it for next pointer and then we will simply point this way. So what are the different operations we are going to have? First one is add or insert. In case of arrays, directly we will insert the element using index, right? So in case of arrays, I have to insert it position 5. Position 5 means A4 equal to I will give the value. But in case of linked list, we don't have any index because these things are randomly allocated in memory. So the only pointer which I know is my first element. So first element of the linked list is known as head and the last element of the linked list is known as tail. Here I am assuming that I want to store the elements in sorting order. I want to insert 5. So what we have to do? We have to create a new node. So assume that this is memory location is 100, 200 and 300. So this 5 memory location will be like something around 900. Let's assume like this. So we have to add at the beginning means currently this is the first node. Now it has to 5 has to be updated as first node means I have to update head from this node to this node. So how, first of all, how we will do? First we will make a link from newly created element to the existing head node and we will update head to this node. So just in order of one time we can able to add at the beginning. There is no need to shift the elements like arrays. I'm creating the node and I'm just making one link to the current head node. So this takes just order of one time complexity. So second one is add at the end. So for example, so I have to insert 40. Here we are maintaining two variables, right? One is head, another one is tail. So if I have to add at end means tail is going to be helpful because if we are going to start at head, we have to travel till end and then we have to insert the new element. So how we will do it? Again, similar way, I just create a node whose value is 40. So for example, this memory location is 1200 and then mark tail dot next to newly created node. Now this node is going to be tail of the linked list. This is how we will add at the end. So in this video we are just discussing what are the different operations and algorithm we will discuss in next lecture. For example, I got value 25. So means I have to add in the middle, right? So what is my current list looks like? So now I got new value 25 which I have to insert in the linked list. The position should be here and we have only two pointers, one is head and another one is tail. Tail is here. To reach here we have to traverse from head node only because we know that what is the next node. We don't know what is the previous node, right? From tail we can't start it because every node we are having what is the next node. So means we have to start from head and once we reach 20, we have to create a new node. Just create a new node with value 25 and then 25 next we will make it as 30 and we will break this link and then 20 next we will make it as 25. So this insertion, just this insertion takes order of one time complexity. So this traversal takes even the order of n time complexity. Just inserting in the middle takes order of one time complexity. In case of arrays, we have to first we have to know the position, that takes again order of n time complexity and we have to shift all the values. What are the values we are going to have? All the values we are going to shift to the right side. So that takes order of n in case of arrays. So all these three, just inserting, we are just taking order of time, one time complexity in case of linked list. So what is the third one we have performed? Add at the random position. So second one is delete or remove. So currently this is the linked list which I have after performing the add operations. Now let's see delete operation, how it is happening in linked list. So delete operations also again will happen same as add operation, means we can delete at the beginning, we can delete at the end and we can delete a node which is in some random position of the linked list. So first one is delete at the beginning. This is the first element, right? Suppose if I am going to delete this element, this has to become my first element or head node. So then how we will do it? So the head pointer simply we can update to the next element. Then that means that this node is going to be deleted. So what we are doing it is just one line operation. head equal to head dot next. So means what is the time complexity? Again order of 1 only. Now let's see delete at the end. So what is the last element in the linked list currently? 40. Means we are deleting 40 means tail has to be updated from 40 to 30, right? But can from 40 can somehow get what is the previous element to 40? No, it is not possible. Means we have to start from head, and until we reach this point we will stop at this point, and then we will make this node dot next to null. Then we will update tail to here. Reaching till this point is taking order of n, but just deleting is just one line statement only. It's just taking order of n time complexity. So deletion at the end overall takes order of n time complexity. Now let's see delete at random position. Now let's see we have to delete 25. So again here also what we have to do, we have to start from head only. We travel till here. So this is the node we are interested to delete, means one node before we have to stop, and we have to mark 20 next to the 30th. Then automatically this node will get deleted because we are removing the reference. So again this deletion is just order of 1 only, but traversal is again order of n, but deleting this node just we are marking the 20 node next to 30, right? This is just order of 1. In case of arrays we have to shift all the elements who are right side of 25 to here, right? So but in case of linked list this is not the case. So this just takes deletion just takes order of 1 time complexity. Now let's see traversal. So we have already in these algorithms only we have already performed traversal, right? For example, I have to delete in the middle. I have to traverse till here, means always we are going to start from head node. So we are going to start from head node, and then we will move every time we will move one step. So this way we are going to traverse the linked list. So traversal is most frequently used because if we want to print the content of the linked list, we have to traverse, and if we want to delete node at some position, again we have to traverse. So deletion also we are using traversal. Only off the way or until that point we are going to traverse, delete or add operation. And if you want to search whether an element present in the linked list or not, for example, I want to know whether 30 present in the linked list or not, then again we are going to traverse from head, and then we will compare the content, we will compare the value of the current node with 30, is it matching or not, then accordingly we will do it. So in such operation also we are going to use the traversal. So we have already covered search operation. So just search operation whether given element is present in the linked list or not. So these are the operations we are going to perform on linked list. One is add or insert, delete, traversal and search. So now let's discuss advantages and disadvantages. First we will talk about advantages. If you notice it, we are not defining any size for the linked list. And whenever we have to insert a new element, we are just creating the element, and then we are marking next pointer to the newly created element, right? So it means that size is growing, and whenever we are deleting it, size is decreasing. This is dynamic in nature. It's not like arrays. So arrays are fixed in size. That is the biggest disadvantage. But linked list is dynamic in size. So first advantage is it is a dynamic data structure. So it means that it grows or shrinks easily. Second one is already we have seen that adding at the end or beginning just takes order of 1 time complexity. So once we know the position, add or removing node takes just order of 1 time complexity. So like arrays, linked list also base data structure which is used to create many other data structures like queues, stacks, etc. So we are going to study about these data structures in detail in further lectures. Now let's see what are the disadvantages. So if you notice it, so linked list, each element is a node. It's not just a simple data type. It is a node. So node means what are the things we are storing it? One is value, Another one is address of the next node, right? So there is some extra space needed to store these links or pointers, next pointers. Second one is we are not able to access the elements of the linked list randomly. So for example, we are having linked list like this, and I want to know what is the value at position 2. Again, we have to start from head node only, and then we have to traverse. So one more disadvantage what we have seen. So if I want to delete the last element, I just have to mark my previous element as the last element, right? But definitely we are not going to know what is the previous element. Means we don't have reverse traversal. So this is not there in linked list. So even though we know which element we have to delete, it is tail, but still we have to start from head. So this is one such use case. So because we are not having reverse traversing, we are deleting last node in order of n time complexity, right? So this is the one more disadvantage. Reverse traversing is not possible. Arrays, I just printed at sixth index. Then I can print at fifth index in order of one time because random access is possible. But we are not going to achieve the same thing in linked list. So this is the introduction about linked list. So in next lecture, we are going to write algorithm for these all operations and we will write code implementation in Java programming language. I hope this video is helpful to you. Thank you for watching. Stay tuned.